Let's see the Eisenstein Criterion in action. So P is a prime, F is a polynomial with integer coefficients. If we satisfy these three properties, then we can show that F is irreducible over the rational numbers, and you can't factor it. In order for this to be true, for that prime number, you need this to not be 0 mod p, you need the rest of them to be 0 mod p, and you need this one to not be 0 mod p squared. In other words, the same prime number divides all of the numbers, not the first one, and its square does not divide a 0. That's what's required. So let's check it out. X to the fourth plus 3x squared plus 12x plus 15. We want a prime number that goes into all of these. 3, clearly. So the prime is 3, and this is a 1, so 1 is not congruent to 0, mod 3. 3 is congruent to 0, 12 is congruent to 0, 15 is congruent to 0, all mod 3, and 15 is not congruent to 0, mod 9. All of those are satisfied, therefore this polynomial is irreducible. Let's try it on this one. Let's check for the prime number 2. These are all even numbers, looks promising. This is not divisible by 2. These are all divisible by 2, but it fails because this is divisible by 2 squared. So how do we fix that? We try a different prime, because all of these numbers are also divisible by 3. So we get another chance. 1 is not divisible by 3. This, and this are all divisible by 3. And this is not divisible by 9. Those are the requirements. Therefore, this is also irreducible. Notice I couldn't prove that with 2, but I could prove it with 3. So you might be hunting through prime numbers to try to find one that will work. Another example, x cubed minus 3x squared plus 3x plus 1. The only prime number that has a chance is 3, because 3 goes into this and this, but it doesn't go into this. So it looks like the Eisenstein criterion fails here. However, we can use a bit of algebra on this. You might recognize that 1331, that this is very close to being x minus 1 cubed. But the difference is that should have been a minus 1 for that to work. I mean, if it was a minus 1 here, then we could just say, okay, well, we just factored it, so clearly it's reducible. But instead of having a minus 1, we have plus 1, so we have that. So here's the trick. If we just say that y is x minus 1, we're talking about y cubed plus 2. We can use the Eisenstein criterion on this. The prime number we'll use is 2, because this is not divisible by 2, everything else is divisible by 2, and this is not divisible by 2 squared. Therefore, the Eisenstein criterion is satisfied. This is not reducible over the rationals. Therefore, this is also not reducible over the rational numbers.